Organizations now understand the transformative power of AI and are transitioning from legacy platforms to modern cloud environments. A typical platform migration journey involves assessing and planning the migration, code transformation and optimization, and end-to-end testing, validation, and deployment. This platform modernization and code migration is a laborious process, often taking 5+ years for global enterprises. Challenges include a lack of documentation for legacy code, unclear dependencies, and redundant code needing identification before conversion. Familiarity gaps with data and programming languages hinder optimal migration, while lack of standardization leads to subpar results. Additionally, insufficient automated test coverage and data integrity issues make testing and validation difficult. Overall, traditional migration approaches remain manual, time-consuming, and inefficient. At EXL, we've redefined migration using agentic AI with EXL Code Harbor, our Gen AI-powered multi-agent solution. Code Harbor integrates a network of AI agents, each purpose-built and fine-tuned to handle specific migration tasks, mimicking how a human team would work collaboratively. These specialized agents focus on different aspects of the migration process, refining their outputs through collaboration, ensuring a seamless, efficient, and high-quality transformation with minimal manual intervention. This approach optimizes the entire modernization lifecycle, driving both cost efficiency and performance. Now, let me walk you through how each agent works. The process starts with the Code Assessor agent, which evaluates the complexity of the code and understands the interdependencies. This is instrumental in downstream planning and orchestration of other agents. Next, the Business Analyst agent plays a critical role in understanding and documenting the business logic embedded within the code. This step is especially critical when documentation is missing or outdated, ensuring enterprise teams gain clear insights into the logic and can effectively prioritize conversions. The Data agent then generates detailed metadata, which captures all the tables, attributes, and transformations in your code. It also maps data, table, and code lineage, analyzing dependencies across the application hierarchy. This detailed mapping of information also enables enhanced data and code governance, ensuring transparency in data flow and providing deeper insights into related data structures. As a first step of the code transformation phase, the Code Simplifier agent breaks down complex and often lengthy code into logical, structured segments. This chunking of code requires proficiency and fine-tuning for each source language and makes it easier for other agents to understand and process efficiently. Building upon the foundation set by the previous agents, the Code Migrator agent, customized for each source target language pair, translates the code while maintaining its functionality. Next, the Optimizer agent further refines this transformation, making sure the output takes full advantage of the target language's strengths, instead of just being a direct line-by-line translation. Together, these agents produce an initial transformed version of the code, which is then tested and further refined. For creating the right test cases, we need to first establish the data to execute the pre- and post codes. In absence of production data, our Synthetic Data Generator agent can fabricate test data, which reflects the original data features. This module reduces the dependency on data readiness in the new environment and provides flexibility for edge case testing as well. Once the test data is generated, our dynamic orchestration engine enables iterative testing and debugging of the converted code. The Code Executor agent runs the code in both the source and target language environments, producing logs and outcomes that highlight any discrepancies. These are fed into the Debugger agent, which is equipped with configurable goals and constraints, continuously refining the migrated code, identifying and resolving errors, and proactively flagging areas that may require human intervention. At the conclusion of this agent-driven workflow, Code Harbor provides a fully converted, tested, validated and optimized target language codebase, ensuring it is clean, efficient, and ready for deployment. Leveraging the potential of agentic AI, Code Harbor accelerates, refines, and validates every stage of platform modernization. We have significant business impact across multiple dimensions, not only ensuring faster, better, and cheaper migrations, but also providing enhanced governance and compliance.